Think the audio. Okay, why do I have a feeling I'm using the wrong microphone? No, it was correct. There are two settings for this one. I'm not sure which one's which one's better. This one should be the same quality but a bit louder. That should be okay. Hopefully we have the sound from the PC. So can you guess what this image is? Or what is this robot meant to be doing? So we're asking O3, ChatGPT O3, because it's using advanced reasoning. And it went all to town analyzing the image. Let's see what it reckons. Okay, so it's obviously focusing, well, not obviously, it started focusing on the robot itself, on the robotic arm, which is fine. Yeah, going all to town, the details, I don't know, looking at the screws or something. Using Python to plot, yeah, it keeps focusing on that bit. I think because it's found some text in it, so it's actually trying to analyze that. Yeah, it's trying to extract some text, whatever. But yeah, I was just asking it to focus on the yellow bits in the image. It's the original image. I don't know if you can guess what it is. So when asked to focus on the yellow image, yeah, it's again, was thinking for almost a minute, which is ages in machine time. Yeah, focused on that. Weirdly interior, it doesn't know what it is. I think it's not using the web. If it was using the web, it would be able to determine. But then, yeah, it's able to actually get in the right direction. So this could be soft tissue. Yeah, it mentions the cochlea. And yes, it is a model of a cochlea. Shallow circular recesses. Tinted PDMS. Yeah, sounds right. There's soft elastomer. Spiral groove. Yeah, it says the robot arm is a high precision force position device. Looks like a force dimension haptic manipulator. Yeah, probably is. The chessboard, the pattern is used for calibration. Yeah, we're actually asking to focus on that yellow bit there on the bottom left. And yes, when making a final guess, let's just read this out loud.
Final, best educated guess. Robot. A high-precision 6DOF haptic force feedback manipulator looks like a force dimension omega or delta head on a custom mount. In the lab, it's driven in teleoperation or autonomous mode to practice fine needle tool insertions while measuring subnewton forces and submillimeter motion. Yellow pieces, cast translucent polyurethane or PDMS phantoms that mimic human soft tissue, specifically the inner ear, cochlea, and generic layered tissue. The little heart-shaped capsule with a spiral channel is almost certainly a cochlear phantom used for practicing and studying cochlear implant electrode insertion. The larger kidney bean block with 3-stepped circular pockets is a calibration deformation target. Each recess gives a known curvature and depth so the robot can probe, feel, and the vision system, that chessboard marker, can track exactly how the material deflects. Purpose together, researchers are tuning force control and path planning algorithms for minimally invasive surgical robotics, especially cochlear implant surgery and other micro-otology procedures. 1. The chessboard lets stereo cameras calibrate the workspace. 2. The robot inserts a microtool electrode into the soft phantoms. 3. Sensors record the tiny forces, and vision measures deformation so they can validate safety before moving to cadaver or live tissue. So in short, a surgical robot test bed for cochlear implant and soft tissue manipulation research, using yellow elastomer phantoms as realistic stand-ins for the human cochlea and layered tissue.
And of course, you cannot not use Blu-Tack to hold the model in place. But yeah, obviously it's a demo, and that thing is just the logo. I would imagine it's not actually practically used in this case. But yeah, the robot was able to determine what the robot is used for correctly. It's a cochlear implant in robotic insertion. Well, in this case, prototype. There supposedly are clinical grade robots like that used in cochlear implant surgeries. To check if that's actually accurate. There are no links. There's one system by Medel and another one by Colin Medical. The second one seems to be more generic. The research project or are the clinical systems? Hey, can we actually find the commercially or research grade robots that are used in cochlear implant surgeries? Yeah, we're not doing another deep research, just using a regular search with 4O, not to be confused with O4. I'm sure there will be already a lot of jokes on the naming of these models. Okay, now it's actually giving images and sources and everything.
Yes, there are both commercially available and research-grade robotic systems developed for cochlear implant surgeries. Here's an overview of notable systems. Commercially available systems. One Hero Surgical Robot. Developers Mediel, Austria, and Cassination AG, Switzerland. Overview. Hero is the world's first robotic surgical system designed for high-precision, minimally invasive cochlear implantation. It utilizes advanced image-guided surgical planning software, Otoplan, to identify the optimal trajectory to the cochlea, allowing for a precise 1.8 millimeter tunnel access to the inner ear. Regulatory status received CE mark approval in 2020, enabling its use in clinical settings across Europe. Key features: image-guided surgical planning with Otoplan, minimally invasive access to the cochlea, integrated safety features, including continuous neuromonitoring and real-time torque monitoring during drilling. Clinical use, successfully used in multiple European centers, including the Medical University of Vienna. More information. 2. IotaSoft Insertion System. Developer, IoTA Motion, USA. Overview. IotaSoft is a robotic-assisted insertion system designed to aid surgeons in the placement of cochlear implant electrode arrays by controlling the speed of implant insertion, aiming to reduce insertion variability and trauma. Regulatory status, granted FDA De Novo classification, making it the first and only FDA-authorized robotic-assisted insertion system for cochlear implantation. Key features: thumb-sized, bone-mounted robotic device, compatible with various cochlear implants, designed to integrate seamlessly into existing surgical workflows. More information. Research-grade systems. 1. RTorg Center's Robotic Cochlear Implantation System. Developer, RTorg Center for Biomedical Engineering Research, University of Bern, Switzerland. Overview. This system is a dedicated, image-guided, safety-assured, task-autonomous surgical robot developed for cochlear implantation. It has been used in clinical trials with 5 patients implanted using the robotic technology. Key features: image-guided surgical planning, safety-assured, task-autonomous operation, designed to operate within the visuotactile limits of manual surgery. More information. 2. KUKA KR3-based system. Developer, adapted from KUKA GmbH's industrial robot. Overview. This system is based on the KUKA KR3, a 6-joint light robot adapted for cochlear implant surgery. It uses a commercially available sterile disposable syringe as a hydraulic cylinder for automated hydraulic actuation. Key features: automated hydraulic actuation using a disposable syringe, designed for precise control during electrode insertion. More information. These robotic systems represent significant advancements in cochlear implant surgery, aiming to enhance precision, reduce invasiveness, and improve patient outcomes. If you're interested in more detailed information about any of these systems or their availability in specific regions, feel free to ask.
Yeah, we could make a simulation on something like that. How would you go about making a simulation of an electrode array being inserted into a cochlea? Ideally, it will be a game like interactive simulation and anatomically accurate. Any ideas are welcome. Our question is what model should we use for them for this kind of prompt? We do have a bunch of cochlea related stuff on the page, mainly this simulator. You can also change filters and the number of electrodes. Go check it out on the page. Yeah, that's a bunch of ideas. Can we somehow make it using essentially vanilla JavaScript? If any visualization libraries are required, that should be okay. Then all that data can be in a JSON file and wrapped up in HTML, including inline CSS styling. So all in one continuous script code in one file. Yeah, don't generate any code yet. Just instructions for a JavaScript developer. So what the cochlea model will be? Do we have separate models for the cochlea, the ear, and the electrode array, or how many models do we need? Hey, can you also give me like a continuous text summary, plain text?
If you're a JavaScript developer and you want to make an interactive simulation of an If you're a JavaScript developer
If you're a JavaScript developer If you're a JavaScript developer and you want to make an interactive simulation of an electrode array being inserted into a cochlea, you can totally do it in vanilla JavaScript, all wrapped in a single HTML file. You'd use a canvas element for rendering and bring in something like Three.js via CDN for 3D visualization. The cochlea and electrode models can be kept really simple. Maybe a JSON structure embedded directly in the page, defining things like the cochlear spiral shape and electrode segments. You don't need full medical detail. A visually accurate spiral with a transparent cochlear tube and a bendy electrode going in will do the trick.
You'd simulate the insertion by letting the user drag the mouse or tap keys to control the electrode's position. Internally, you track how deep it's gone and simulate insertion force, just a basic calculation like force increasing with depth and maybe a bit of randomness. If that simulated force goes beyond a certain threshold, you can trigger a warning like tissue damage to make it feel like a real surgical risk. On top of the canvas, you could have simple overlay UI elements, like a depth meter or a live force graph. You might use chart.js for that, or even just draw on another canvas. Everything, JavaScript, CSS, and JSON data, can live in the same HTML file, so it's fully self-contained. The 3D cochlea model can be really low poly, just enough to give a sense of the anatomy. And to make it educational, you could include an option to show part labels, a simulated CT scan background, or even a planned path overlay that guides the ideal insertion route.
Yeah, why are we doing it low poly? Can we make it essentially hyper realistic or more realistic than not?
Great question. And yes, you can go for a hyper-realistic or high-detail model if your goal is to push the realism. The main reason I mentioned low poly earlier is just to keep things light, fast, and easy to manage in a browser, especially when you're working with vanilla JavaScript in a single file. But if you're not constrained by performance or file size too much, and you're okay using external CDNs or large embedded assets, there's no reason you can't go for high realism. To make it hyper-realistic or at least more anatomically detailed, you'd want to.
Use a high-resolution 3D model of the cochlea, maybe from a micro CT scan or medical dataset. These can be found in scientific datasets or anatomy repositories, like the Visible Ear or Body Parts 3D. You'd convert these into a format usable by 3.js, probably GLTF, OBJ, or even a baked JSON version.
Going for realism will make the experience more immersive and useful for training or demonstration, especially if your audience includes clinicians or researchers. It just means you'll need to think more about performance optimization. Example, decimating the model slightly, loading textures efficiently, etc., and possibly host larger assets externally if they don't fit in a single HTML file.
Do we have all the knowledge required to create all the code from scratch? So it's actually working?
Yes, we absolutely do. You or we, working together, have all the knowledge required to build the entire simulation from scratch and make it actually work, even with realistic 3D models, physics-like interaction, and browser-based rendering.
Yeah, okay, go for the code. So start with 4.0.
The base simulation code is ready. It's a fully self-contained HTML file with inline CSS and JavaScript. It includes a basic 3D cochlea-like shape and a movable electrode that you control with the arrow keys. Let me know if you want to add a more accurate model, curved electrode physics, or features like real-time collision or anatomy labels next.
I can preview it. Okay. Okay, it's good we previewed it so we don't have to waste more time. So that's what's for all. Can we regenerate? No. To understand the canvas. Okay, can we generate the whole code? I'm not sure which model do you think we shall use. Let's go in the same order. Okay, it again went for the canvas. That should be fine. A 3GS via CDN. Is that what's that meant to be? And why is it surprisingly so similar to what we had before?
I've placed the complete single-file HTML simulation ready to run in any modern browser in the canvas to the right. Load it locally or from a static host and you'll have a working, interactive cochlear implant insertion demo. Let me know if you'd like adjustments, added realism, or extra UI touches.
Okay, the keyboard. The keyboard meant to do something. Ah, no, it does. Yeah, the keyboards are working. Where's it getting that odd shape? I have no idea. Yeah, once it has had to generate the code from scratch. Wait, we have two of those. Yeah, that's a common error with 3GS with the orbit control. It's actually trying to fix it. Let's see what happens. Yeah, the simulation is pretty rudimentary at the moment, so That was the one for O made. I went for O3. My understanding is that O3 is the only complete model out of, so O4 is not the actual model, it's like a miniaturized version of it. So O3 should be better in theory. So he edited all this code. Yeah, we've seen these errors before as well. It might actually work locally if the CDN is correct. Yeah, the CDN seems to be correct. But we are getting the same error. We are getting the same error. Okay, this is actually a bit more interesting. It's a bit like a Christmas tree. Can orbit and everything. Okay, that is very interesting. Something is working. So the simulation, everything technically is working, but it doesn't. Yeah, it does. The shape looks like a cochlea, but then it doesn't have any volume. So can you tell me where the electrode array meant to be inserted? I might need some volume to the cochlea structure. And then the electrode array, I don't know if those are electrode contacts, but it doesn't look like an electrode array. It's meant to be a ring contacts embedded in silicon. So it's meant to, yeah, look like an electrode array. I think if you can explain the structure. If you can also add the instructions and overview at the bottom of the page, that will be great. Can we generate another code from scratch? The cochlea implant, so the cochlea, the electrode array, meant to be ring electrodes embedded in silicon-like elongated structure that will be able to insert into the cochlea. So the cochlea actually needs some volume to it, so we can insert the array. And if we can add the instructions and overview at the bottom of the HTML page, that will be great. So all the code generated from scratch. Now also we would like a mouse control, so we can actually move the electrode array using a mouse. We can move it in and out, and it will curl across the cochlea, and the depth is shown as on the depth will be shown in millimeters on the screen, and the force is shown on the screen measured based on a mouse motion. So we are simulating a surgery. But if we can generate the code from scratch in another canvas or in the chat, that's fine. Okay, this is interesting. So it's actually working fine. There's one obvious issue that when we trying to move the electrode to insert the electrode into the cochlea, the whole 3D scene is panning, which is not ideal. Not sure how to fix it. And also, the other thing is that the rings, yeah, currently it looks like a gold chain or something. I like the metallic look of it. If the metallic look could be silver instead of gold, and then the rings meant to be parallel to the cochlea, so different orientation. Yeah, meant to be looking like an electrode array, similar to like a deep brain stimulation electrode arrays. Let me know if you know what I'm talking about. Very nice. Love it. Yeah, we have the force, we have the depth. That all looks legit. And then we have that warning, tissue damage risk. That's really nice. Maybe when there is no warning, we can indicate when moving the array, we can indicate that it's safe. So like have like a green, yellow, red type of text with appropriate, with relevant label, text label. Now, any chance we can still pan the scene when moving like the outside the electrode array? So when we actually click on the electrode array, we are inserting the electrode array, but when panning outside the electrode array, we want to pan the whole 3D structure, if that's possible. Also, while we making changes, can we also make the rings a bit smaller in radius and elongated? But the orientation is correct at the moment. Any suggestions how to make the colors better? Yeah, I like the color of the electrode contacts, the silver metallic, but everything else can be adjusted. If we can make the background color lighter, that will be great. And also the shape of the cochlea meant to be tapered. If let me know if you know which way what the shape meant to be. Okay, just in the chat, any issues with this simulation that you can see? I can see a couple. Maybe limited to two main issues. First, with the shape of the cochlea. Is it meant to be narrow on one end and wider on the other? And then with the electrode array, with the distance between the electrodes meant to be identical, meant to be the same as we move it along as we push it into the cochlea. Otherwise, the simulation is perfect.
I see two small things worth double checking. 1. Cochlear taper. Anatomically, the cochlea is conical. It's largest at the base where the electrode enters and steadily spirals inward to a much narrower apex. In our last version, we flipped the exponent so it now tapers inwards, i.e. wider at the start, narrower at the end. But the exact rate of taper, we used an exponential fall off, may not match the real cochlear spiral. If you need a more faithful shape, you could switch to a simple linear taper, e.g. R equals R base, R apex, tape like a max, or tweak the exponent so the diameter at the base feels roomy enough for the array. 2. Uniform ring spacing. You ask that the distance between each ring electrode remain identical as you insert. Under the hood, we're using get point at T, which maps T to arc length and evenly stepping T by 1 ends 1. So the rings are already spaced at a constant millimeter per segment along the path. If you ever switch to get point instead, which interpolates by parameter, not length, you'd see non-uniform spacing. But as long as we stick with get point at, that spacing is truly equal every time. Let me know if you'd prefer a different taper function for the cochlea, linear versus exponential, shallower or steeper. or if you'd like to confirm the exact base apex dimensions you're targeting.
That's pretty amazing what it can do. I have to keep testing it. Hopefully we get the feedback from an expert as well. And we'll keep improving it. And everything we do is available on our website, bindychaos.com. Hey, go check it out and let us know what you think. And I'll see you next time. Bye.